Well, we're going to build us a little React snake game in this tutorial. And this is what we're going to build. I'm not going to style this one because I want to fit everything in just 100 rows. And that's why I'm not going to style it. So maybe a fun challenge for you to do yourself to give this some fresh styling. And it works just as a regular snake game. You use the arrow keys on the keyboard to control the snake. And you have this little start game button down here. So start game. And as you can see, our snake is growing as we take this little, it should be an apple, but it's a kind of light bluish square here now. And I made this little snake pink in this one. So you can, of course, choose whatever color you want. And I actually provided you with some starter files for this one. And that's because I'm going to give you the constants for the game here in a file that's called constants.js, and also use interval.js. This one is a custom hook built by Dan Abramov that we're going to use for instead of using setInterval. It's not working that great with React. And you can read all about this at Dan Abramov's blog overreacted.io, and he'll explain everything in detail there. So I'm going to provide you with this one and also this one with the constants here. So you may say, well, this is more than 100 rows. Okay, it is. I'm cheating a little bit here because if you include this one and the use interval, it will be more than 100 rows. But we are going to write this one here. That's the app.js, and it's exactly 100 rows now. So I think that will demonstrate that there's not that much code you need to do stuff like this. And if we take a look at the constants here, we can just try to change stuff here. For now, this one is 800 times 800 pixels. And I also set a scale to 40. So if we set this one to 0, you can see that we don't see anything here because it's just 1 pixel. We can set it to 10. And the snake and the apple will not scale that much. So I set it to 40 because we want to see it on the screen. So you can try to change these ones. And the speed, of course, is the speed, how fast the snake should move. And we have the directions. And this is just a JS object with the different key codes that we're going to use in the code later. So it's just an array with X and Y coordinates. So for this one, X is 0. That means that we're not moving on the X axis, but the Y is -1. That means that we're moving up 1 segment. And for this one down, we're not moving on the X axis, but we're moving down. So this one should be a 1. That means that we move 1 segment down. And we'll use this one in our code, of course, and talk much more about it then. And I also provided this snake start. That's where the snake is going to start, obviously, in this playing field. So it's almost in the middle, not exactly. You can play around with this, but make sure that you don't allow the snake to go diagonally. I think that's the word in English. Because you couldn't do, for example, like this. This is not allowed in the snake game. So I change this one back. And also, if I try to show you here, don't know how I should show it, but if I go, for example, up with up arrow and press down, it will die because we can't change the direction just by pressing the opposite direction. Then it will crash against itself. And this is also, if you don't want this behavior, this is stuff you can do later on to kind of modify this game to get better, because I'm just giving you the basics here. So that's what I'm going to fit in 100 lines of code. And of course, you could also have some score count and stuff like that, but we're not doing that in this tutorial. Okay, so let's start coding. Okay, I switched to the starter files now. And if you download the starter files, you have one folder that contains the finished game. And you also have a folder that's called React-snake-start here. It will give you this screen if you start it up. You just navigate into that folder, type npm install. In this case, I just created an application with create React app. So I'm using that one for this tutorial. When you install all the dependencies with npm install, you just type npm start. And hopefully you should have this screen here. And that will tell you that it's working. And if we take a look inside of this folder, we have the index.js file. It just shows the app here. It just rendered this one to the DOM. And you have the app.js. And this is the only file that we're going to modify for this game. And as I told you before, you have the use interval.js and the constants.js. All right, so let's start here. Inside of the app.js, we just have this little div here that tells us that this is the snake game. And the first thing we can do now is to import all the stuff that we need for this game. We're already importing React, but we're also going to use state for this one, use ref, and use effect. And these are just regular hooks that's built into React. I'm not going to go through this in detail because I have other courses and tutorials on how to use React hooks. So I'm assuming that you know a little bit about React and also React hooks before you take this tutorial. All right, so importing these ones from React, I can actually make this one a little bigger. Then we're going to import the use interval that I showed you. That is a custom hook that's built by Dan Abramov. We're going to use this one. So import use interval from /use interval. All right. Then we're going to import all our constants inside of this file here. So import. We have the canvas underscore size, and these are all capital letters here. We have snake underscore start. We have the apple underscore start, the scale, the speed, and directions. So this will be all our constants. And make sure that you check the spelling here so you get them correctly. And we're going to import these ones from ./constants. And it will complain now because we're not using them anywhere. That's all our imports that we need. And we can start modifying our app component. And we have to think about this because when creating stuff like this, I think you should break it down and really think of what functions do you need to get this to work. So I'm just going to scaffold out the functions now, and we're going to fill them out as we go along in this tutorial. First of all, we can just create curly braces around this one. And then we need to have the return statement here. We can move this one up inside of the return statement. And here we can start scaffolding out the functions that we need for this one to work. And first, we're going to need a function for us to start a game. So we can call that const start game, camel casing. I use arrow functions. You can use regular functions if you want to do that. And this one is just going to be empty for now. And we obviously also want to have a function for us when we end the game. So that's two functions. What else do we need? We need to have a function that moves the snake. Const move snake. We're going to need a function that will create an apple for us. Const create apple. And we're going to need some type of collision detection. And I've divided these ones into two different functions. I have one where I can check if we hit the walls and also if we hit the snake itself. And I have another one where we check if we collide with the apple. So first, const check collision. And then we have another one that's called const check apple collision. All right, what else do we have? We're going to have a game loop. Const game loop. And then we're also going to have a use effect that will trigger whenever we update the snake apple or set the game over. So we can actually scaffold this one out also. Use effect. We have an inline arrow function. And we need to specify a dependency array for this one. And this one is going to trigger when the snake, apple, or the game over states are changed. We haven't created these states yet. I will do that in a second. All right, and that's it for our functions. It may look a lot now, but it really isn't that much to create this type of game, because now already we have half of the code written already. We have 50 lines of code, so we just have to write 50 more to get this to work. And first, we can actually create our canvas here inside of this return statement. We can remove snake game. We have the wrapping div. This one is going to have the role of a button. And that's because this is the div that's going to register when we press an arrow key on the keyboard. We also need to set a tab index of 0, I think, otherwise React will complain, as this is a button. And then we set on key down. And when we press a key down, we're going to have an inline function here. Then we're just going to call move snake. And that's one of the functions we created up here. I can actually remove this sidebar. So that's our wrapping div. Then we can create our canvas. I'm just going to give this one a style with a border so we can see where the canvas is on the screen. So I set the border. It's going to be 1 pixel solid black. Then we're going to use the use ref hook for this one to reference the canvas so we can get the values from this. So we set a ref to the canvas ref. We haven't created this one yet, so bear with me. We're going to set the width of this one. And here I created template literal. So we have backticks, $, curly braces, and we grab our canvas size. And from this one, we have X and Y coordinates in an array. And the X coordinate is in the first array element. So we set a 0 there. And then we just add a PX and end it with another backtick. No, the PX should go like this. And then we can just copy this one. And we set the height. And we grab that from the index 1 in the canvas size array. And of course, we have to close the canvas like this. All right. I think this will give us an error if we save this one now. Yeah, it will, because I haven't created this one yet. And we're going to create the states just in a second. But first, we can also have a little expression here that will render out game over if it's game over. So game over, and then we do a short circuit here. And then just render out the div with game over like this. So we're going to create a state, and if this is true, it will trigger this one to render. So then it says game over, otherwise it will do nothing here as we have this short circuit. If we have 2 ampersands here, that means that if this is false, it will just do nothing. But if this is true, it will show the div on the screen. Then we're of course going to have a start button also. We have an on-click handler on this one. Start game. We have our function that we created that's called start game. We can just type out start game inside of the button. So that's all of the JSX that we need for this one. We have to create these states also that we're going to use here. And we create these states at the top in the component. First, we're going to create the ref to our canvas. So const canvas ref. And then we imported this use ref up here. So we use ref and we set it to null. So we're creating this canvas ref const here, and we also reference it down here in the canvas. And that's why this one will be connected to the canvas so we can get the value in this const. All right, then we have a few states we need to create here. We have our snake and set snake equals use state. And for starters, we give it the snake underscore start. That's our const that we imported up here. And then we have another state that's going to be the apple and set apple. And this one we use state and we give it the apple. And we give it the apple underscore start. Use state, not state, use state. All right. Then we have another state. We call it dir and set dir. This is the one that is going to keep track of which direction we're moving in. Use state, and we give it an array of 0 and -1 for starters. And this means that we're going up because we have -1 on the y-axis. Then we have another state with a speed and set speed. Use state, and for starters, we give it null because we don't want it to move before we have pushed the start button. And the last state that we need is game over, and set game over. Use state, and we set that one to false. All right, and we save it, and I think this will give us this nice little canvas, and our start button here, it will do nothing now, but at least we have our canvas here, and it's set to 500 times 500 now. I can actually boost this up to 800 and 800, and I scale this one up to 40. And I think also that we may change our snake position, set it to 8 and 7 and 8 and 8. I will change this one to be included in the starter file, so you don't have to change this yourself, hopefully. Okay, yeah, save this one and back into the app.js file. And this should give us a much bigger canvas here. So that's great. Back inside of the code editor, I remove this sidebar. And I think the next step to do is to actually get something to show up on the screen. We want to show our snake and one apple to begin with. And if you remember, we have our use effect down here, and this one is going to trigger whenever the snake, apple, or game over states are changing. This is the one that actually draws things to the canvas. First, we have to get the context from the canvas. So we create the context, and we have our canvas ref. And from that one, we have a key that's called current. And from that one, we get context 2D. And this is just how the canvas works. You have to get the context to be able to draw with this context on the canvas. Okay, then from our context, we are going to set transformation. And we have our scale const. And then we have 0 and 0. Then we have scale again, and 0 and 0. Make sure that you get this right. And what this will do is every time when it renders, when it updates, we have to set the scale also, because we could set it with this one and just give it scale and scale. But this one will actually scale up from where it was in the last render. So if we set this one scale to 40, next time it will add this one to 40, and that's no good. So we have to reset it every time, and you can do that with context.setTransformation, because if we do it like this, we set the scale each time to whatever we defined in our scale const. So that's why I'm using that here. You could also, instead of doing this on each render, you could create another use effect that initializes this one time at the beginning, and then you just have it saved in a state. But I wanted to keep this one on 100 rows of code, so I'm doing it like this now. But this will make sure that we always scale up our canvas to our scale const, whatever value we define there. We also have to clear the canvas and draw our new stuff on the canvas. So context, clear rect, React, clear rect. Okay. 0.0. And then we have our window dot inner width and window dot inner height. You could also set this one with, yeah, maybe that's better actually. We have this one that's called canvas size. We can use that one here instead. Canvas size. This one is the X. And this one is the Y. So this one will make sure that we clear our canvas before we start drawing anything in this render. Then we set the context fill style to pink. This one is for the snake, it's pink. And then we have our snake. It's in the state now that we call snake, and we can just loop through this with a for each loop. I'm going to destructure out the X and Y here. And we draw this one in the canvas. We do that with context.fillRect. Should be a capital R. And then we have our X value and our Y value. We set it to 1 and 1 because we're drawing with 1 pixel, but we are scaling it up with our scale value here, but we're just drawing it with 1 pixel. And this is really neat because we don't have to bother on how big the snake should be here. We just set the scale on how big we want it to be. And that's why we just can have 1 pixel here. And that's really neat. That's everything we have to care about. All right, so that's our snake. Then we change the color of the context fill style. And I choose a light blue for the apple. And then we draw another rectangle. So context.fillRect. And we have our apple in our state. And we have the X value as the first array element. And we have the Y value as the second array element. And yet again, we're just drawing 1 pixel. And this is it. This should actually give us something on the canvas if we save this one now. And of course it won't work. We have some error here. Context.setTransformation is not a function. All right, we have to check this one out. Set transform. It shouldn't be transformation. Set transform. And I'll save this one again. And as you can see, we have our snake and our apple here, so it's working. But nothing else works now. We're going to fix that now. So back inside of the code, we're going to make our sad little pink snake to move and also get something to eat so it can grow a lot bigger. So I think the next step we could do now is actually make it move when we press the arrow keys on the keyboard. And this one is going to be really easy. Actually, we have this one that's called move snake up here. We don't even need the curly braces because we're going to create a one-liner of this. As I said, I'm going to try to squeeze this in 100 lines of code. Then I have to maybe not make it as readable as you could. So you'll have to live with that one. This one, when we move, we can check that out down here. This is the div here. We have the on key down. We have the event. And we call the move snake. And we send in the event. And from the event, up here, we can actually destructure out the key code. And I already created this object for us that we call directions. That's in the constants.js file. So we can just set the state, set dir, and from the directions, I'm just grabbing the key code that we get here. So as we push a key, we will get the key code, and we have our state up here that's called dir and set dir. So we set this state with the value from our constant that's called directions. If we check this one out in the constants.js, I have this object here with the different key codes. So it will grab the correct key code here and give us this little array here with the directions. So nothing will happen now. We have to move the snake also, of course. So we're going to create a movement for the snake now. And for that one, we have the game loop. We have that one down here. So inside of the game loop function, first we make a copy of the snake. We don't want to mutate the state. You should never do that in React. So we create the snake copy and equals json.parse parenthesis JSON stringify. And we send in our snake. And this one will make sure that we do a deep clone of our state because our snake is a multidimensional array. That's why we have to deep clone it. And this one will give us a fresh copy of this multidimensional array. Okay, then we create a new snake head. And I have to remove this one because this one is going to be quite long. So we have new snake head camel casing. Make sure that you type it in correctly. First, we're going to calculate the new x coordinate. And we do that by checking the snake copy. The first element in this one is the head, and the first element in the head is going to be 0. So this one is the X position of the head in the snake. And then we just add the direction, the X direction to this one. So from dir 0, this is the first element in the dir state that we have. So this is the direction for X. Then we have a comma, and we're going to set the Y coordinates. Yet again, we have the snake copy. That's the first element in the array. And this time we want the Y coordinate. So we grab the second element in that array, and that's the 1. And then we just add the direction 1. So think about this for a second. It may look a little bit complicated now, but it really isn't. Because here we have the snake copy. That's our complete snake. Our head is always going to be the first element in the array. So we can grab that with snake copy, and the 0 element here, that's going to be the first one. And from that one, we have another array, and we know that the X coordinate is the first element in the array. So we can grab that one, and then we just add our direction to that one. And direction is just one array. So the first element is going to represent the X coordinate, and the second one, that's the 1, is going to represent the Y coordinate. So that's why when we add this direction to this one, we get the new value of the snake head. If you don't understand this fully now, I suggest that you pause here and just think about it one extra time so you really understand what's happening here. Then we're going to mutate the snake copy. The snake copy, we're going to unshift this one and just attach the new head to the start of the array. And we do that with unshift. So we have the new snake head up here. So this one will add the snake head to the current array. Then for now, we can just remove the last element in the array. And this is the way that the snake is going to crawl through the playing field. We add our new head to the top, to the first element in the array, and we just remove the last element of the tail in the array. And this way it will look like it crawls. So for now, we're just removing the tail. We're actually not going to do that later when we eat an apple, but for now, we just remove the last element in the array, and we can do that by calling snake copy.pop. This one will remove the last element in the array. All right, then we can set our new snake state. So set snake, and we send in the snake copy, and this will update the state. And nothing will happen here yet, because we haven't started the game loop with the use interval that we're going to do now. And we import this use interval up here. That's the custom hook that Dan Abramov created for us. It works almost the same as the set interval in JavaScript. So we can use interval. We send in our game loop, and then our speed. And actually, it will complain now because I'm calling this before it was defined. So we can actually move this one down below every function here. Make sure you put it just above the return statement. So we make it the correct way here. You shouldn't call these ones before you have defined the functions. So I say this one, and it will not move now because we have not given it a value. Now, of course, we have to create an inline function here also. And as you can see, it will not move now because we have set the speed to null. But if we change this one to 1000, it should move once a second. And as you can see, it's moving up now, and we can control it. Yes, I think we can. We just have, make sure also, because we set the key controls on this surrounding div here, so you have to actually make sure that you make that div active. Otherwise, you can't control the snake here. And it works, as you can see here now. But it's a little bit slow. It should move faster. So I think we'll change this one to 100. Yeah, and it's really, really fast now. That was too fast. Set it to 500. Make sure that you click on this one here so it is highlighted. Then you know that you can control the snake. You could, of course, set this one on the window or something to listen for the keys instead. That would probably be a better idea, to be honest. But all right, we have a working snake. We can control it in different directions and it will move. So this is great. Now we just have to make it eat apples and make it so it can collide with the walls. All right, so we set this back to null. This will make it so it won't move. Okay, we can actually create our start game function first. Inside of this, we're just going to set a lot of states here. So set snake. We reset it to snake underscore start. Set apple. We reset that one to apple underscore start. We set the dir. Whoops. Set dir. And we give that one an array of 0 and -1. That will make it move up on the screen. Then we set the speed to our speed that we define in our constants. So we have this speed here. And then we set game over to false because we start a game, so it will not be game over. So that's our start function. And as we're here, we can also set our end game. When our end games, we're going to set the speed to null. We're canceling the interval this way. We set game over to true. This is everything we have to do with the end game. All right. How many rows are we at? We're at about 80 rows, so we have 20 more rows to go. So we have to do some collision detection, and we can start creating this function now. We have to do 3 types of collision detection. We have to check so we don't collide with the walls, and that's the first one that we're going to do. We also have to check so we don't collide into ourselves, and that means if we turn around and we move into the tail of the snake, it should collide. So that's the second one. And we also have to check collision when we eat an apple. So I divided these 2 up. We have the check collision and check apple collision. And inside the check collision, we're going to check if we collide with the walls or the snake itself. So we're going to give this a few parameters. We have the piece. We're always just going to send in the first piece. That's the head of the snake, because that's the one that's going to collide. So we're always giving it just one piece of the snake. So we're just going to check if the head of the snake is colliding with something, and that's going to be the piece here. Then we're going to give it the snake, the complete snake. And I'm actually going to call this SNK inside of here, that's the snake, and give it the default value of the snake. This is the snake that's in our state. And why am I doing this? Yes, I'm going to use it to check when we move the snake. And I'm also going to do this to check where we actually create a new apple. Of course, we're going to create a new apple on the playing field randomly. And we don't want that apple to be able to pop up inside of the snake. So we can check if the newly created apple is inside of the snake with this check collision function. And if it is, we just continue on creating new random apples until it's not inside of the snake. But we'll get to that one when we create the check apple collision. For now, first we have to check if we collide with any walls. So if the piece that we send in, the piece 0, that's the x value, and we have to multiply it with the scale to get the correct value. If this one is greater or equal to the canvas size and the width, we have that value as the first element of this array. So this is the width. Then double pipes there. Then we check if the piece 0, that's the x value again. If that's less than 0, then we should collide. Then double pipe and piece 1, that's the y coordinate. We multiply this with a scale. If this is greater or equal than canvas underscore size and the y value, double pipe and piece. I will explain this more in a second. And the piece, this is the y coordinate. If this is less than 0, then we will collide. So this one will make sure that we can't run into the walls without colliding. the first row here, this is the x coordinate of the piece. The piece is the head of the snake. And we just multiply this with a scale because we're scaling up the canvas. So we have to multiply it with a scale to get the correct value. Then we just check if this is greater or equal to the canvas size. So this is how we get the correct value here. If we have a 0 here, we don't have to multiply it with a scale because it will give us a 0. And then we can just check if this one is less than 0, then we know that we are colliding. And we do the same thing with the y coordinates here. So we can try this out inside of our game loop somewhere below here. If, and we call our check collision, we send in our new snake head. Because we're always one step ahead here, we're sending in the snake head before we have actually set it in the state. Because we want to first check that it don't collide. So we do this first before we do anything else. So check collision, new snake head. Then we call endgame. And of course, we also have to return something here. So this one should return true if we collide. Otherwise, we return false. And as you can see here, I've left out the curly braces here in the if statement, and that's because I want to save rows here. It's a little bit less readable, but I'll save me some rows here so I can squeeze this in on 100 rows. So save this one. And of course, we have to change. No, actually, I think we can just press the start button. Yeah. See what happens. Yeah, we have a game over when we enter that wall. We have a game over on that wall. And we have a game over on that wall and also that wall. That's great. So it's working. So that's our wall collision detection. Then we have to check so we don't collide with the snake itself. I actually think that this one should go like this. To check if we collide with the snake, we can just loop through the snake and see if the new head has the same coordinates as the piece in the snake. So for const segment of SNK, that's the snake up here. If we don't send in one, as we don't do in this case, it will default to the snake in the state. All right, then if piece, and we have the 0, that's the x coordinate. If that one is equal to segment, and the 0, that's the x coord of the segment, double ampersand, then we check the y values, piece, and 1 equals to segment 1. Then we just return true, because then we know that we have collided. So we loop through the complete snake here and see if we have the same coordinates in all the segments as the piece. Somewhere, if we have that same coordinates, we just break this one and return true. So that's why we're not using for each for this one, because you can't break out over for each. That's how we check the collision with the walls and the snake itself. And I think now it's just 2 segments long, but yeah, I did some quick movements there and it collided in itself. And then we have a game over. And this is also the one I told about. If you try to change in the opposite direction, it will collide. And maybe you don't want that behavior. So you have to make a refactoring of this one if you don't want that behavior. Okay, we're at 93 rows. Okay. We're going to create the check apple collision now. And for this one, we're going to send in the new snake, because we want to check if the new snake collide with apple. And first we check if new snake, and the first segment as before, it's the head, and we check the x coordinate of the head. If that one equals to the apple 0, that's the apple x coordinate, and double ampersand, we have the new snake 0, that's still the head, and now we have the y coordinate. If that equals the apple and 1, that's the y coordinate. All right, and inside of that one, something will happen. So we're just checking if the new snake head has the same position as the apple. Okay, then we create a new apple. Let new apple create apple. We call that function that we actually created up here. And this one, we can remove the curly braces and save us some rows. And we're going to create a new random apple here. And we can do that by map through our current apple. Apple.map. Then we have our coordinate here. We're not going to use the first value. We're just going to use the I value here. That's the counter. You could do this in many ways, but I do it like this because it was a little convenient just to using this to get the length of the apple. Math.floor, and then we math.random. We multiply it with the canvas size. And y. This will give us the two different positions. And we just divide it with the scale to get it in the correct units that we're using for our game. So this will give us a random apple. All right, so this is how we create a new apple. And then we have to check if the apple that we create collide with the current snake. As I told you, we're going to reuse this function up here. And as long as we collide with the snake, we're going to create a new apple. So we can use a while loop here. While check collision, we send in the new apple that we created, and we send in the new snake. And as long as this one is true, we know that we're colliding, so we just create a new apple. Create apple. So this will keep running until we create an apple that's not colliding with our snake. Then we set the apple with the new apple. We return true because we have collided, we have eaten the apple. And then below here, we return false because we're not colliding with anything. And then we just have to call this function somewhere, and we can do that in our game loop. Just below here, when we've checked if we collide with the walls or the snake itself, we can also check if we eat an apple, if we collide with an apple. So if not, check apple collision. We send in the snake copy to that one. So I'm using the exclamation mark here because I'm going to check if we're not colliding. Because if we're not colliding, we're going to pop off the tail of the snake. Otherwise, if we eat an apple, we don't need to pop off the tail because we want the snake to grow one segment when we eat an apple. So snake copy.pop. This will make sure that we pop off the last element, that we remove the last element if we're not eating an apple. But if we're eating an apple, we will keep the tail as it is. And we can remove this one here. So save it. And I think that this should be it. Yeah, we're at 100 rows exactly. That's great. So save it and we'll try our game. Is it working? Yes, it's working. We're eating the apple and the snake is growing. And that's great. So this is how we create a snake game in 100 rows of code in React. I'm not telling you that you should do this in React. It's just fun to make some experiments sometime. It would probably be easier to make it with vanilla.js. And we are colliding with the walls. Yes, that's great. It's working. I'm actually a little bit proud of this one because I thought it would take more than 100 rows of code actually to get this up and running. All right, hope you enjoyed this one. I'll see you in another one where we create some other cool stuff. And make sure that you also subscribe to my channel if you're not subscribing already.